All right, welcome back, everyone. Hopefully you had a good breakout session. And what we wanted you to do in the breakout section, just to recap, and you can still enter in your solutions now, is come up with up to 3 potential things you should do differently for running a large-scale network design problem. The situation I gave you is that you're operating in Europe, you're manufacturing in a handful of different countries, and you're distributing to all. And so what should you do to try to come up with a plan that you think will be valid for 5 to 10 years out? And so the reason why I came up with this is because, one, this is something that's on everyone's mind who's designing a supply chain right now, and there's some actual cases. So for example, Whirlpool, which manufactures white goods, appliances like washing machines, dryers, things like that, prior to Brexit, where Britain left the EU, they had manufacturing in both in England, in Great Britain, as well as in France, in the southern part of France, for both their dryers and their washers, serving all of Europe. And then because of Brexit, they made decisions, and they decided that the plant they're going to make that's in England will only produce product for England. So it will get a little smaller. And then they closed the plant that was in France and moved it to Lodz, Poland. And so that will provide the rest of the UK. So, the rest of the EU. So what they did is they separated out. Now, they didn't say, I don't know how Whirlpool came up with this analysis, but that's one of the results that came out for how they're changing their manufacturing network. So, Sergio, what do we get from some of the groups?
Okay.
And please keep typing in your options.
Okay, so we have some answer from Param Iyer. So option 1, he says, having a minimum capacity in relevant locations that are prone to uncertainty. Having additional capacity in every plant to buffer for uncertainty. Pursue chaining of product across facilities to manage uncertainty. That's option 1.
No, so essentially what we're saying here is add extra capacity. So the question, I think the big thing is, hopefully people got the idea out of it, you're going to have to run scenarios. It's not going to be a one-time solution and end. And so the real question is, what type of scenario should I consider, right? And what would I change for each of those potential scenarios? And so what he or she put for option 1 is all about, it's almost a solution.
Yeah, it's all about adding extra capacity.
So the whole idea of adding extra capacity and extra inventory as buffer, that could make sense, but look what that would do for that's one scenario where everyone has extra capacity, but how would that help you model the uncertainty? That would help you buffer if you think there's going to be demand uncertainty, but the uncertainty here is different than what we talked about in our classes. It's not just demand uncertainty, which is what I really focused on when I did the New England root beer distributors case. The real issue here is currency fluctuations or tariff changes between countries. So going from country A to country B, what normally costs $1,000 a load might double. And how will that change things? So I think what you did for your first option is a possible solution, but it's not something you would incorporate into your methodology. You're dictating a solution there. But okay, what was the second?
Okay, the second one is having production closer to seaports and airports.
Okay, so that could be a scenario where you move them closer, but then so you just give them more options. But again, I think you're focusing a lot on solutions, not methodologies to come up with a solution.
Okay, and the last one is explore contract partners manufacturing options to address uncertainty.
Yeah. So that's good, but you should probably try to get a little finer grain. But you could, so you're presenting other options. Maybe we use a third party to do distribution where in a new country where we used to have operations because it's kept separate now. No, that's fair. So what would you do, Sergio?
Okay, so in my case, if we talk about the methodology, I think I will try to somehow estimate the potential new cost of the delivery, transportation cost.
Okay.
So for example, UK, or in this case, England would be isolated.
Mm-hmm.
So as you mentioned, the costs are going to be higher.
You assume that's what, I'm guessing that's what they did, where the cost of distributing to Germany or whatever suddenly increased, so therefore it makes sense not to distribute from there. Okay. Okay.
And I think that higher cost will penalize and will look for another options in other places of Europe.
Yeah.
And also, I think the lead time,
Mm-hmm.
so in this case, should be larger than initial. And I think that's what that we somehow should estimate.
Yeah, because the lead time, when we did some of the New England root beer stuff, it was all about how far I can deliver from one DC, because we had we had to deliver within 1 day or 2 day or something like that. You can think of the same thing here. It was seamless. If anyone's traveled in the EU, the borders are frictionless. But if suddenly they become with friction, then it might take more time to clear customs. So instead of a 1 day trip, it might turn into a 1.5 or a 2 day. So that might lead potentially, as those tariffs, as those time commitments go up, to more DCs. And it might lead to an ultimate strategy of every country has its own DC, which is way back to pre-EU days, when every country used to be operated independently from the others. Yep.
Interesting. Okay, we have another potential solution. In this case, is modeling risk management in the model with scores an acceptable overall risk score as a constraint, as AC constraint. So using Monte Carlo simulation on distribution of probability of disruptions.
So yeah, that sounds really good. It's very hard to come up with that distribution of disruptions. So what are the disruptions we're talking about? Currency fluctuations, right? Because the idea is, let's say if France votes out of the EU, if Penn wins the election, what does that distribution look like? The pundits got the Brexit election and the US election wrong. They're just wrong. So what probability disruption do you have for that? I understand if I'm looking for like the probability of a hurricane or some weather or something like that, where you can look at over history. These things, political changes, are not amenable to standard disruption kind of thing. So that's a harder one to do, because that's a go-to for a lot of people. You model it, you assume a distribution. It's a binary event, and so you'd have to almost look and see what would happen there, because some of the other things could happen. They could implement a VAT, a value-added tax. How does that change things? So it's not so easy to say, well, just do supply chain disruptions and model with a probability. That's why it's more of an art now. And so I think what this would end up doing is increase the number of scenarios that you have, and you could try different levels. Because the other thing that I've done in the past for things like this, we tried to find something, for example, back in the early 2000s, the price of fuel was much higher than it is now. There's actually a glut of oil across the globe right now. But when it was very high, we tried to figure out, and this was a project we did actually in Spain, where we tried to figure out what would your DC look like with the current price of fuel, your whole distribution network, and then what would the price of fuel have to do where you would change what your network looked like. And so the one way to do that is do repeated scenarios where you keep changing the price, because your arc rather would increase in cost. And at some point you go from, say, 5 DCs to 3, and it might change, or at 5 to 7, because usually if you increase the arc cost, then you're going to have more DCs closer to your markets, right? So we wanted to find out where that break point is, because then that gives you an idea, do I need to worry about this or not? So one thing you could do, let's say we isolate this down to the whirlpool problem. And we could say, okay, if I'm producing in England and I'm shipping into the EU and the current cost is this, what would it have to be where suddenly it would not make sense to ship, and where I would ship that capacity to some other plant? And you find where that break even is. And if it's 10% more than what it is now, then you want to worry about it. If it takes, a 5x, then you know not to worry about it. So the big underlying thing for this is to do multiple scenarios, and not just to see point solutions, but try to see if you can derive as best as possible where there's a break point, where suddenly your network changes because some underlying factor changes. And some of those would be the transit times, which is a reflection of the customs, currency fluctuations, tax differential changes. So you could do a series of runs to try one at a time what the impacts would be. And if you have more time, to try to change 2 things at once. But generally it's easier to hold everything constant and change one thing, and then have everything constant and change another thing. As you get into changing multiple things at the same time, then it gets a little tricky. But if you think there's interactions, then it does make sense. So that was a long answer, but there is no single solution to this problem. The big takeaway is you need to do multiple scenarios that are smart, not just try it with 10% more, 10% less. You have to think about the underlying cost drivers that would, the political cost drivers that would change your network design.
Excellent, thank you, Chris. We have one quick question about the currency.
Sure.
Yeah. It's but pound depreciated after Brexit, with might still justify exports from UK.
Yeah, that's a good question. It depreciated. Didn't it come back a little bit? I don't know how much it's come back, because there's questions now. It's such a fluid situation. So a lot of times you want to, it's a valid point. You'd say, what would the pound have to go down to where it actually makes sense to keep it in there and distribute it? That it's a valid point. So these models, what's cool about them, you can have all these different assumptions and test different ones. So I could see a simple 2x2 where you look at the differential in the currencies, right? How the pound, if it keeps depreciating, then it might make sense to produce more there. But then the customs and any kind of the trade costs, any barriers or additional costs for distributing, you'd also have to look at the inbound cost for the raw materials and see, does it still make sense to bring that in to England? Does that change things? Because you got coming in for the raw materials, going out as a finished product, and you have to look at how those costs map up against a value devaluation for the pound itself.
Okay, thank you, Chris. And you were talking about these scenarios, and we have a question. Mm-hmm. And we call this sensitivity analysis. This generation of scenarios is the same as sensitivity analysis? Well,
doing scenarios gets you at sensitivity analysis, right? How sensitive is my model solution to certain things, right? And so I can increase, so like in the example I gave with the price of fuel, what we did there was just keep increasing the price of fuel, which naturally increased the cost of distribution. And so at some point you hit something and the network changed. There's always going to be some dead zone where it has no effect. Changing the price of the holding cost by 1% might not have any effect, or it might be right at that break point where it totally changes things. It's always helpful to know where your parameters are, because then you need to make a quick decision. Do I care? Should I care about this? Or is it something that's really important? Or is it something that, you know what, the value would have to increase by 10x for it to change my underlying structure? And that's the trick. That's the art, to try to get, one, to identify what those drivers are, and then two, how do I incorporate them into my model? Because all the model does is fixed and variable costs on nodes and arcs. That's it, right? That's all that it really does. So you have to try to take the political and map it in to the things I have available for me in the model.
Okay, thank you. And we have another question from Ed. Does this problem mirror what many manufacturers had to deal with in operation in Hong Kong and facing the July 1, 1997? They changed in governments.
Yeah, that's, you know, I'm not sure exactly what they did in 97. I think there's less manufacturing in Hong Kong, more trade for that, but I know a lot of decisions were being made there when Great Britain, they had the handover back to the Chinese government for Hong Kong, and it's still evolving, because remember, nothing was supposed to change, and now there's changes happening. So I'm sure they did for scenarios, maybe for different industries. I think it affected the finance industry and shipping industry more than pure manufacturing, because I think by that time a lot of manufacturing had left Hong Kong for cheaper labor locations. But absolutely, there was a lot of uncertainty about what would happen as soon as the government changed. Same thing happens in Latin America all the time, right? Because there's a lot of uncertainty. Look what's happening in Venezuela. General Motors just pulled out of Venezuela as a whole because the state took over, appropriated its plans. So this stuff, the political stuff, it's so hard to predict. And that's why in basic classes, we usually say, okay, look at demand fluctuation, because the political stuff, it's tough. And as you'll see, if you take SC2x, a lot of the decisions of where to locate plants and DCs and things, it's driven by taxes. And so we'll talk about a case where the pharmaceutical industry, there's a reason why most of it moves through Puerto Rico in the United States. It makes no supply chain sense, but it makes incredible tax sense because of incentives that are there. There's a reason why Ireland is known for a lot of medical devices. It's a tax incentive. So with these political things, changes, a tax incentive can be changed overnight. And so if you build your supply chain on stilts and suddenly one of the stilts gets chopped off, then you've got to rebalance yourself. So that's why the political uncertainty seems like it's not as important. It is what drives a lot of the financial incentives and taxes that underlie most supply chain network designs at a global level. And so your trick is, part of the art is, how do I incorporate these softish kind of things that I don't know with certainty into the modeling, which has very hard levers that I can change? Fixed and variable costs, nodes and arcs, and then some kind of constraints. Yeah, so it's a challenge.
We have another question. Would it be fair to say that we need to model against the outcomes, transit customs, and not really the event, the election in this case?
That's a really good point. So in SC2x, I talk about scenario planning, and this would fit into some of that. And the beautiful thing about scenario planning, what we talk about is, instead of trying to predict the future, and I call it like boxing, where you try to do a point forecast, everything we did in SC1x when we did exponential smoothing or causal analysis, we come up with a point forecast like boxing. Where scenario planning, it's you say, here's an outcome, how would I adjust to it? And so when we talk about scenarios here for network design, we're saying the world is going to look like this. What would your supply chain look like in a world like this, when customs takes twice as long, the trade barriers of a certain amount? So what we're doing is we're saying there is a situation, how would you have the optimal design in that world? And so what this allows us to do is move away from trying to predict different events to understanding their effect. So that's the challenge. For an event could be Brexit. It could be the same effect that Brexit caused could have been caused by a war, could have been caused by a certain pandemic, where you can't have things coming in from England to the rest of the coast. Think of the zombie apocalypse if it happened, right? But anything like this, there are many, many, many events that will have the same effect on your supply chain. And so one way to boil the ocean and not try to predict every possible event that could happen is to think back, what are the main effects on my network? And for the case with Whirlpool, it was where to manufacture and where to distribute from. So the idea was, if England gets isolated, then it can't produce out. What would that's an effect. There might be many events that cause that. So I think what the question was, can I focus on the effects and not the events? Because it's impossible to predict and forecast events from happening. It is easier to prepare for effects that are caused by multiple potential events. Did I answer the question?
Yeah, I think so.
Okay.
Thank you, please. We still have time for a couple of questions. I think we don't have any.
All right.
Any final comments, Chris?
No, I think I've talked enough.
Okay, excellent. Thank you. So thanks again, guys, for joining this first Hangout. Just a couple of reminders. The verification upgrade deadline is May the 3rd. Okay, we have two due dates for data assignments. The due date for week 1 data assignment is April 26th. That's tomorrow. And the due date for week 2 data assignment is May 3rd. So you have 1 extra week for this homework. Okay, so enjoy the material and see you next time.
All right. See you guys. Bye-bye.